me show you something interesting. This is some video footage of flight simulation. It's put out by a company named Evans and Sutherland in Utah. I'll show you. What you see here is a computer-generated image of an airplane in flight. Now we're seeing from the vantage point of the pilot. But the important thing to realize is that we're not just seeing pictures here. Actually, the pilot has controls, and as he moves his controls, the scene changes as though he were flying an actual plane. This is an actual three-dimensional simulation of a real scene. The pictures are not just two-dimensional pictures, but there's an actual model which is generated within the computer, and the pilot is seeing the model from a certain perspective, namely the perspective of an airplane, a simulated airplane. So in effect, the pilot is put in the middle of a simulated world. So here we see him flying over a forest, and now two planes fly by. Now in this sequence, we're going to see the fighter pilot make a simulated bomb run on a nuclear power plant. Watch what happens. He's looking for the plant, veering this way and that. Here it is, it's coming up. So there the bombs hit the plant. Now we see from the point of view of the ground, the airplane goes over. So I should apologize for the somewhat blatantly military nature of this footage, but we have to recognize that most of the advances in modern computer technology are due to the interests of the military. They would like to simulate battlefield situations so that they can train pilots and get experience in warfare without having to actually do the real thing. But this has led to very interesting technical developments in the whole area of computer science. And it leads to the question of what is the relation between simulation and reality? Now, we saw these pictures. We saw that the pilot is actually placed in the scene by the computer technology, so that as he works his controls, it's as though he's looking out the window of his airplane, seeing the world and interacting with it. This is happening in what is called real time. I should explain that term. Real time means that as the events are happening, the computer is generating the pictures. This computer generates pictures at 60 frames per second of the changing scenes, so that you actually see it in natural order of events. It's not merely a recording of something that was computer generated earlier. So this question of computer simulation is a very interesting one. In the very beginning of the modern age of computers, people were thinking of even more ambitious simulations. Here we're just simulating the flight of an airplane over an area of terrain, but then people were thinking of simulating an entire human being. This started with a British scientist named Alan Turing back in the 1940s. He was interested in whether or not a machine could think. And so he was describing how you might simulate a human being using a computer. In such a simulation, all of the different aspects of the action of the human mind would be duplicated within the computer. And Turing argued that if you could do this, in effect, you would capture the reality of the human being. Now, the idea behind that is that the essence of the human mind, or the human being, lies in the relationships between little parts that make up the human mind. This is the idea that the mind is equivalent to the brain and the action of different elements within the brain. So later on, these ideas were developed over many years, and in more recent times, this idea of artificial life has been introduced. Recently we went to a conference in Santa Fe, New Mexico, put on by Los Alamos National Laboratories, mainly the sponsors came from there. And the theme of this conference was creating life within a computer. The idea is that you create an entire world, a simulated world or simulated reality within a computer, and within that simulated reality there are simulated creatures. Just like here we saw the landscape with buildings and so on. These buildings are actual three-dimensional models represented on a three-dimensional model of the terrain. So the model has all the different relationships within it corresponding to the reality which is being simulated. So the basic theme in this conference was that life, in essence, is a set of relationships. This is ultimately the materialistic idea that life is just a matter of a combination of molecules. When the molecules are combined into certain relationships, then that's life. And there's no subtle essence of life or anything like that. It's just a question of putting the atoms in the right relation to one another. So if you can put the atoms in the right relation to one another, then you've got life. If you put some other parts in the same relationships, the same relative relationships to one another, then you should also have life. So one point of view here is that if you simulate life, if you create a simulation in which you capture enough of the relationships between things, then even though this is taking place within a computer, still it's as good as the real world. It's captured the essence of reality. So this is the argument that was being made. In fact, at this conference, some footage was shown from Evans and Sutherland, and we'll show some of that later on, illustrating this idea of simulating a reality. So not everyone agreed with this idea, however. One dissenting opinion was expressed by a philosopher there named Elliot Sober. He said that, well, if you simulate a bridge, let's say if you're an engineer and you're interested in stresses and strain in bridge construction. So if you simulate a bridge within a computer and the bridge collapses, no one would think that that's the same as the collapse of a real bridge. It's merely a calculation, a simulation. But then another computer scientist there from MIT named Tommaso Toffoli replied to that by saying that, well, if you had simulated people driving in simulated cars across the simulated bridge and it collapsed, then they'd fall to their simulated deaths. And since you captured all the relationships there that exist in the real world, that'd be as good as reality. So this leads to an interesting question. What is the relation between simulation and reality? Are they really equivalent? Could you say in some sense that reality is a simulation? So that's a question we want to explore here today. Now this is an interesting image. Simulated people in a simulated world. But even if you could capture all the different relationships that go into the human body and the environment, would you actually be able to duplicate consciousness? For example, in this simulation, notice this little figure here who's making semaphore signals. Of course here, the little figure is not even intended to be conscious. And you would tend to think that, well, this is just a computer-generated image. There may be a three-dimensional model there, but it's mere calculation. Or look at this helicopter taking off. Once again, one would think there's mere calculation going on here. Surely there's no consciousness, even if you do capture all the different interrelationships between the different parts. So the question is, how could you have consciousness in a simulated world? So this is a very interesting question, because the same question comes up if we look at the real world. In the real world, you have molecules, you have different physical constituents of matter fitting together in certain relationships. How can there be consciousness in the real world? This is one of the basic questions that comes up in this whole area of artificial intelligence. Some people have argued that if you capture all the relationships that go into the brain, into the processes of thought occurring within the physical structures of the body, then you must capture the very essence of thought. But what about consciousness? If you could capture all these different interrelationships and duplicate them in a computer, would the resulting model actually be aware? Just as right now I'm aware that I'm speaking. I have this conscious perception of what's going on. You can well imagine a robot that would be speaking just as I am, but just like that semaphore signaler, there'd be no consciousness there. It would merely be a structure going through motions. So there's a philosopher named John Searle at UC Berkeley who has discussed this at great length. He argues that just because a computer program simulates all the different relationships that go into conscious thought, that doesn't mean that it will be conscious. Simply because a program is being executed with all the relationships and all the parts, that's not enough to give you consciousness. He gives the example that the computer could be made of many different kinds of things. And he gives his famous Chinese room example, in which the computer consists of a group of people exchanging notes on slips of paper, which well, give answers to questions posed in Chinese, and yet the people themselves who are executing this program don't know anything about Chinese. So he asks, would there be consciousness there of translation or speaking of Chinese or answering of Chinese questions? And he says, well, if there is such consciousness there, where is it? The individual people are not aware of Chinese. The group of people as a whole presumably has no awareness, it's just a crowd of people. So just because a program is being executed, he argues that you wouldn't have consciousness. But now when it comes to the brain, he makes a different point. There he says, well, consciousness is there in the brain because of the basic brain molecules that are there. If you have specific polypeptides and so on within the brain, that will generate consciousness. But now again, if you go to an organic chemist and ask him, well, what is the essential thing about a molecule, say a polypeptide, he'll say, well, it's structure, it's the relationship between the molecular components. So we're back to the same question again. We have relationships between molecules, or relationships between electrical currents forming patterns within a computer. What's the real difference? In either case, you just have relationships. So you can raise the question then, well, how is it then that you have consciousness in the brain? The question is really very much the same as the question of, well, how could you have consciousness in a suitably complicated computer? Now, the interesting thing is that it may be that modern computer science has inadvertently handed us the answer to this question. We've already seen this to some extent with this flight simulation footage, because there we see how you can put a person into the picture. When you see the jet plane flying over and bombing the nuclear power plant, as a matter of fact, that is conscious in the sense that there is a human being whose consciousness is projected into the location of that jet plane, and he's controlling it. But it turns out you can go even further with this. This particular simulation is actually a creation of a company called VPL, located in California. So here we see a hand, looks like a disembodied hand, trying to throw a switch which runs this fan. You can see the fan there on the ceiling, and you'll see that the fan turns on or off depending on the setting of that switch. So the hand is trying to throw the switch. But the important thing here is that this hand is connected to an actual person. And also the senses of that person, the sense of sight in particular, are linked up so that he's seeing from the vantage point of this hand, or rather really from the vantage point of his head, which is just behind the hand. This is a somewhat strange simulation because you can see objects tend to pass through one another. This is because actually it's very difficult to calculate where different elements of surfaces intersect one another. So you really need a very powerful computer indeed to properly calculate when objects are passing through one another. So here we see the hand, which is the hand of an actual person trying to pick up this pyramid. He's handing it to another person. As you can see, there are actually two people in this scene. These are two real people, and their consciousness is projected into this simulated world. So each person is seeing the world from his own vantage point. We're seeing from the vantage point of the first hand, and the other person is seeing from the vantage point of the eyes of that head and torso. So he's trying to manipulate an object. You see him looking at his hand there briefly. Both of them are trying to move these different objects around. There we see an example of instant growth within the simulated world. So in this situation, we have a creation of a reality by computer simulation in which consciousness is actually present. So how is the consciousness of a human being projected into the simulated world so that the human experiences himself or herself as actually being in that world? Well, this is done with the use of appropriate interface apparatus. In the case of an ordinary computer, a person has an interface. He has a keyboard with which he can give instructions to the machine and a screen so that he can see what's going on within the machine. So here one simply needs a more direct and a more complete interface. In this still rudimentary system developed at VPL, there are basically two elements to the interface. The first is a thing called a data glove. The person wears a glove on his hand which has optical sensors which record the exact movements of his finger joints. So this makes it possible to project the movements of his hand into the simulated world. And the person is wearing a device which they call iPhones. It consists of two TV screens which go directly over the eyes. These screens enable the person to see from the perspective of the simulated body within the simulated world. So now we'll look at a bit more of this VPL footage in which we see the human participants within the simulated world from the outside. That is, we see their bodies as they're experiencing life within the simulated world. Let's take a look at that. So here we see a person wearing these iPhones. There's the data glove. Now we see superimposed the person and the simulated hand in the simulated world. As you can see, the hand is moving as the data glove is moving. So the person is not seeing both these things. He's merely seeing within the simulated world from the perspective of the simulated head within that simulated world. So here you see him operating within that world, reaching for things, grasping for things that are in the simulated environment. So now we'll show a couple of additional scenes illustrating the nature of this simulated reality. The first thing we'll show is an example of two people trying to shake hands within the simulated world. So here they're again manipulating objects within the simulated world. And now they're going to try to shake hands with each other. As you can see, it's a little bit awkward. They're not accustomed to this. And there's the problem that their hands pass through one another. So a lot of work has to be done to improve the simulation. but they're actually experiencing themselves within that world, trying to shake hands with one another. Actually, the experience of being projected into another world can be a little bit disorienting. Consider this example. Here we have a person who's projected into a simulated world, and as you can see, literally, he's experiencing another reality. He's seeing, feeling, perceiving in a different world. This leads to interesting questions involving the psychology of conditioning. Here we see a person in a simulated world who is experiencing a new sensory realm. The relationships between the different sensory inputs that he is receiving and the elements in the simulated world may not be exactly the same as in his ordinary experience. So one question is, will this always seem unnatural to the person? Or will the person be able to adopt to the simulated world so that that becomes natural for him? Well, there's an interesting experiment that sheds some light on this.
At the turn of the century, a famous experiment was conducted in which a subject wore spectacles that inverted the world. To start with, there were the inevitable errors. After a week or so, the subject not only began to adapt his behavior, but in order to retain deeply held beliefs, such as gravity acts downwards, he began to see the world the right way up as well. From then on, he was able to get about perfectly normally. But if we can change what we see, seeing must be more than merely passive observation.
This experiment with the inverting lenses can be carried out in an even more remarkable way using simulated worlds technology. Because, of course, in the case of the inverting lenses, one aspect of the person's perception was altered by this simple expedient of the special lenses. But using a simulated world, one can totally change the sensory situation of the individual. For example, here you see a computer-generated butterfly. Actually, this was created with our own personal computer. But you can imagine a simulated world in which the senses of the individual are projected into the butterfly so that the person actually sees from the perspective of that simulated butterfly. And also you can imagine that the person's tendency to move will cause the wings of the butterfly to flap or the legs to move and so on. So the person could actually experience the world from the sensory viewpoint of a butterfly. And the question could be raised, could the person adapt himself to that situation? That is, would it eventually come to seem natural to him, or would it always remain completely artificial? One could actually investigate this experimentally. I suspect that one would find that the person in many cases would be able to actually adapt himself to the simulated environment. Actually, this is similar to what happens when you learn to drive a car. Initially, the motions that you're producing with your hands and feet are unnatural, and one has to think very carefully about how certain motions translate into certain movements of the car. But after a while, it becomes second nature. So this idea of introducing a person into a simulated body involves a number of interesting questions. One point that we haven't brought up thus far is the question of the brain of the simulated body. In the simulations that we've seen, the simulated body does not have a brain. The external senses of the individual are directly routed to the external senses of the simulated body. And thus when the person moves his hand with a data glove, the simulated hand moves exactly in the same way. However, in more sophisticated simulations, such as the one I was just describing, it would be necessary actually to have a simulated brain going along with the simulated body. The idea of a simulated brain and a simulated body is not new. Actually, people are already doing experiments in which they simulate a brain and a nervous system using a kind of mathematical model called a neural net. And this neural net controls the motions of a body within a simulated world. So this kind of research is already being carried out. And you can imagine interfacing a conscious human being through an appropriate sensory interface with a simulated brain. In that case, this person could be operating within the simulated world, using that simulated brain. So here we see an example of a seagull taking off. It's a little bit of video footage that we took. Imagine what it would require for a person within a simulated bird body to be able to fly. Obviously, it wouldn't do to have the person flapping his arms so as to control the flapping of the wings. That would be too awkward. But if some appropriate stimuli, even perhaps taken directly from the nervous system of the individual, were to control the brain of the bird, then that in turn could control the flapping of the wings. In one sense, this is already being done with these flight simulations, because in a flight simulation, you'll have a automatic pilot which is controlling the motions of the plane. The pilot in the simulator is controlling the automatic pilot, and that in turn controls the plane. So it's actually possible to introduce a brain into a simulation. So this leads to further questions. For example, when we do something in this world with our ordinary brain, we learn, and the brain becomes modified so as to reflect that learning. So if a person was linked up to a simulated body with a simulated brain, one can ask, well, would that simulated brain be learning? Of course it would. The person would be learning with his own brain, and he would be learning with the simulated brain. And it would be interesting to see, for example, which one learned more, or to what degree the learning was apportioned between the two different types of brain. So all of this leads to, once again, this question of the brain and consciousness, which we'll now come back to. The question is, could it be that the reality in which we experience our day-to-day existence is itself a simulated reality? Could it be that we are actually conscious entities projected into this reality of our experience in much the same way as a participant in a simulated world is projected into that simulated world through some appropriate sensory link-up? Of course, it may seem that this is a fantastic idea, but if we think about it, we can see that this idea is not actually so fantastic at all. Let's just review some of the ideas about simulated worlds that we've already been considering. We've considered the idea that the essence in producing a simulation is to duplicate the relationships which exist within the real world. And we considered that the essence, as far as modern science is concerned, of what you have in the real world is relationships between parts. The essence then of life is that of relationships between molecular constituents and the various components that make up the body. And this applies to the world in general. So if this is so, as we've already argued, the world in a sense is a simulation. But there's this one missing element, the element of consciousness. How does consciousness get introduced into the simulation? So if the world already is a simulation, at least up to the point of understanding the structure of the different entities within this world, then perhaps this problem of consciousness has the same solution as the researchers at VPL have been investigating. Namely, that you can introduce the consciousness of an already existing entity into the simulated world through an appropriate apparatus. Of course, this has very serious implications, because it suggests, first of all, that if this is just a simulated reality, there must be some real reality, actually real reality, beyond this. This would be called a transcendental domain of reality. Now, of course, this is leading inexorably into many different themes that have been explored in the past. We can go back as far as the time of Plato. Plato, of course, had his famous story of the cave, in which you had a person, a number of persons actually, chained within a dark cave. And as a matter of fact, they were looking at a simulation. They were seeing scenes projected on the wall of the cave. And they were so conditioned through experience of this particular simulated reality that they took that to be the actual world. And then the story goes that somebody came in from the real world outside and tried to explain to these people that you're just looking at a simulation, and they wouldn't believe him. So similarly, we can imagine a conversation taking place between two people within a simulated world. Imagine that this is a very realistic, advanced simulation of the kind that might be developed in the future with much more powerful computers. So the first person is basically a person who understands his situation. He knows that he's merely participating in a simulation. But the second person has forgotten this. He thinks that his actual reality is within the simulated world. So you can imagine them having a conversation in which the first person says, well, actually this world is unreal, and my true existence is beyond this world. And then the second person could reply, well, what do you mean? Show me this world beyond that you say exists. I don't see it. And the first person could reply, well, of course, wherever you look, you see the simulation, because your senses are completely hooked up to this simulation and channeled through it, so that's all you can see. So you can imagine how that conversation would go. It would be very difficult for the person who was trying to argue that he had some reality beyond that simulated world. It would be very difficult for him to convince the skeptic, and yet it might actually be true that he belongs to a different world. Of course, an objection could be raised here, and that is that the world of our experience, this actual world, is running according to certain laws of physics. And these laws of physics do not contain any terms to allow for the intervention of some non-physical mind, which would then control a body within this world. So how then is it possible that we could actually have our existence in some transcendental world and be projected into this simulated world running on a computer of atoms and molecules constituting this physical universe? So this objection can be raised. But the point should be made that you can have physical laws in a simulated world. For example, here we have some more footage from Evans and Sutherland showing a simulation of an automobile traveling over different kinds of surfaces. The laws of physics are used in this simulation to try and predict exactly how the automobile will respond in different real-life situations. So you can ask, in a simulation, how do you interface between laws of physics and the control functions which would enable the consciousness of a person to be projected into that simulated world? In fact, it's theoretically possible to do this. The reason that this is possible is that in the domain of the computer simulation, you're just dealing with computer programs, with software. The laws of physics are represented by software, and the control functions whereby the consciousness of the individual is projected into the simulated world are also carried out by software, and you can interface these two. Now there's a practical feature here, and that is that in order for things to move and transform within the simulated world in a way compatible with the laws of physics, and at the same time to have the individual conscious being controlling the simulated body, you have to arrange things so that very slight effects projected from the participating person can be amplified in a natural way according to the laws of the system to produce large-scale effects within the simulation. Now this is a whole subject which will require many further presentations to go into, but actually you can do this in a simulated situation. So this brings us now to another interesting topic, and that is that this idea of the real world as a simulated world has been spelled out in great detail in a system of thought called the Sankhya philosophy from the Vedic literature in India. And I thought we'd say a little bit about that simply because it's an interesting idea. And it sheds a lot of light on this whole concept of the world as a simulation. So here we see a diagram showing how a computer simulated world can be set up. As you can see, this is divided into three major portions. The main rectangle at the bottom shows the actual model of the simulated reality, the world of 3 dimensions in which the participants will experience themselves as actually existing. So this could be run on one main computer. In a highly advanced system, it would be a very powerful computer. So you can see that above this there is a level where we have interface equipment. Here also computer calculations are being run. For example, for each participant who's being projected into the simulated world, there will be a special computer that generates the visual imagery that that person is seeing from his perspective within the simulated world. These different computations can all run in parallel for the different persons participating in the simulated world. So we have the main 3-dimensional model in the simulation, and we also have the secondary calculations which interface between the main model and the senses of the individual. Finally, at the top level in the diagram, we have the equipment whereby the person actually is linked up with the simulated world. On a crude level, we saw this in the form of these data gloves and iPhones and so forth, used in the preliminary experiments at VPL. Now this second diagram gives the description of the world and the different elements that make it up, given in the Sankhya philosophy. And as you can see, we've deliberately used really the same diagram in both cases. We've merely changed the labels. So I'll just go through the different parts of this diagram. First of all, in the preceding diagram, we had one computer divided into different subcomponents. Actually, these components can be represented by software within the computer. Or, for that matter, they could be represented by physically separate computers. There are various ways that this could be done. So the main component represented by this lower rectangle was the 3-dimensional model of the world. Now in the Sankhya philosophy, that corresponds to the realm of the gross elements. These are summed up in the Sankhya philosophy as earth, air, fire, water, and ether. And that briefly describes gross matter as we experience it in this 3-dimensional existence of our day-to-day lives. So now, above that, in the boxes that we referred to as secondary or intermediary computers, we have labels now of mind, intelligence, and false ego. So these are intermediary functions which, according to the Sankhya philosophy, link the world of the gross physical elements with the senses of the actual conscious entities. In the Sankhya philosophy, the conscious entity is known as the Atma. Actually, each separate individual conscious being is one Atma, and this being is not actually within the world of the simulation, the world of this lower rectangle. And as in the case of the computer simulated world, these intermediary computations or intermediate computers that link the participating individuals with their simulated bodies are not actually part of the simulated world. So similarly, in the Sankhya philosophy, the mind and the intelligence and the false ego, these are functions which are not part of the realm of the gross elements. So many different parallels can be drawn between the Sankhya philosophy and the idea of a computer-simulated reality. Just to mention two other parallels, in the Sankhya philosophy, this world is referred to as the domain of Maya, or illusion. And you can see that, of course, a computer-simulated reality is, in effect, an illusion. Because in one sense it's not there at all, but just like a mirage or an illusion generated by a magician, it seems to be there because of the operation of the underlying computer. So the same idea is there when this material world is described as a world of illusion. There's the underlying computer made of this energy called, in the Sankhya philosophy, pradhan or mahat tattva. But the particular world of changing forms, in one sense, is actually unreal. And another parallel is the idea of this world described in the Sankhya philosophy as the world of names. We can draw an immediate connection or parallel between that and the computer-simulated worlds if we consider that in a computer-simulated reality, all you really have is symbols being manipulated within the computer. So in one sense, that's just a world of names. The problem of explaining consciousness comes up again and again in science and philosophy. The idea that the conscious self is distinct from the brain tends to be rejected in these fields, since it is hard to see how a non-physical self could be connected to the physical body. But considering the developments that we have been reviewing here, it may be that computer science is giving us a clue to the solution of this problem.